Class 9 Science and Technology Part 1 Chapter 1 Laws of Motion.
Part 1.
Recall the definition of motion. Let us observe few of examples. Identify presence or absence of motion in the following activities. First, the flight of bird. Second, train at a platform in stationary state. Third, leaves flying through air. Fourth, a stone laid on a hill. Fifth, an athlete running on a track. So in this all the examples we find that a flight of bird, leaves flying through air and an athlete running on a track are in motion. While that of train at platform in the stationary state and a stone lying on hill are at the rest. The examples states us that when any object is changing its position with respect to its surrounding, then we say the object is in motion. And if the position of object with respect to its surrounding is not changed, then we say that object is at the rest. Now dear friends, to study motion, let us observe this animation.
Dear friends, we all know what this line means. Its up and downs are reflective of the various situations in our life. While the blood is continuously flowing through our arteries and veins, supplying nutrients to all our body. The earth has been spinning since immemorial, creating what we call day and night. But do you know what's common amongst these all events? Of course, movement or motion. Leaving behind past, move on. Movement is life. Think about it. Textbook page number 1. Some questions we are going to answer. First, you are traveling in a bus. Is the person sitting next to you in motion? Answer. Person sitting next to me is not in motion with respect to me, but the person is in motion with respect to a person on the road. Second, what do you take into consideration to decide if an object is moving or not? Answer. To decide whether an object is in motion or not, we can consider whether it changes its position with respect to its surrounding or not. How far you would need to travel if you flew from one location to the several other locations in India? So dear students, distance is the length of the actual path followed by a body between the point under the consideration. In this example, distance travelled by person from Mumbai to New Delhi, New Delhi to Ranchi, Ranchi to Bengaluru is the sum of each, that is 1200 km plus 1000 km plus 1400 kilometers. Therefore, the distance calculated is 3600 km. While on the other hand, displacement is the minimum distance or shortest distance between the initial point to the finishing point. As we calculated, distance from Mumbai to Bengaluru is 3600 kilometers, while that of displacement from Mumbai to Bengaluru is actually 1000 kilometers. and this is the minimum distance, which we call as displacement. Always remember, all distances are approximate values. The SI unit of distance and displacement is meter. Dear students, note that distance is scalar quantity. It requires only magnitude, while that of displacement is a vector quantity. To express it, we require magnitude as well as direction. Did you know? With one complete orbit around the Sun, the Earth covers a distance of nearly 1 trillion meters. This means that the Earth's displacement at end of year is 0 meter. Now friends, let us try this to understand displacement and distance. Point 1. Measure the distance between point A and B in different ways, as shown in this figure, as well as measure the distance along dotted line. Which distance is correct according to you and why? Let us see the answer of these questions. The actual path covered by an object is the distance, while that of shortest distance between the 2 points is displacement. Distance traveled by object across this path is 5 cm and straight from A to B is 2 cm. From this discussion, it is clearly explained the distance measured along the dotted line gives the magnitude of the displacement of particle from point A, that is starting point, to the point B, that is final point. Now dear students, here are the definitions of distance and displacement. Distance is the length of actual path travelled by an object which is in motion when it is going from one point to other point, while that of displacement is the shortest distance covered by an object from initial point to the final point, as we have seen in the previous example. Let us use your brain power and answer this question. Here, Swarali every day moves around the edge of the circular path, which is with the radius 100 meter. We have to calculate the distance travelled by Swarali when she moves from point A the complete one round, and the displacement. As we know, the circular path which Swarali covered is nothing but the perimeter of the circle. So this distance we can calculate with the formula of perimeter of circle, that is 2 pi r. Here the value of r is 100 meter. So we will multiply 2 into 22 upon 7, or you can take 3.14 also, multiplied by 100. On calculating, we will get answer 628 meters if you will take the value 3.14. And if you will take the value 22 upon 7, there will be 628.57 meters. On rounding off, it will be the same. And if you will talk about here displacement by Swarali, then it is 0, because Swarali is starting from the point A, that is the initial point, and comes back to the point A only, which is the final point. Means here the displacement of Swarali is 0. The similar way, if a car is moving in the straight path to reach from point P to point Q,
and covers the distance of 360 meter
from point P to Q, and same car return back from Q to P.
So the distance travelled by car is 360 meter plus 360 meter, that is 720 meters. Since the car reaches back to the same point from where it started, that is the initial point, and final point is same, the displacement of car is 0. So dear students, from this whole discussion, we understand this, even though displacement of an object is 0, the distance travelled by it will not be 0.
Dear students, let us solve this quick quiz in which a sleepwalker walks from his bed through the rectangular path DABC of the breadth 4 meter and the length 7 meter. We have to calculate the distance and displacement travelled by a sleepwalker. So here we can see the total displacement covered by sleepwalker from point D to point A back, while that of distance travelled is the rectangular perimeter. Since the distance travelled by sleepwalker is equal to perimeter of rectangle, so perimeter of rectangle is 2 into length plus breadth. Therefore, 2 into 4 plus 7, which is equal to 2 into 11, that is 22 meters. The sleepwalker reaches back to the same point from where he started. The displacement is 0 meter. The second option is the correct answer. I hope you understood the concept of distance and displacement.
Speed and velocity. Before starting to the next point, can you recall what are vector quantities and scalar quantities? And secondly, which of these quantities, distance, speed, time, displacement, are scalar and which are vector? Let us answer both the questions. So dear friends, a scalar quantity is the quantity that has only magnitude, while the vector quantity is the quantity which has magnitude as well as direction. Now, from the given quantities, we can easily identify that distance, speed and time have only magnitude, while that of velocity and displacement needed magnitude as well as direction. So, velocity and displacement are vector quantity and speed, distance and time are scalar quantity. Speed can be calculated as the total distance covered by an object divided by the time taken to cover that distance, and the displacement taken place in the unit time is called as velocity. The distance travelled by object in a particular direction by an object in a specific time is called as velocity. Both speed and velocity can be calculated per second, per minute, per hour or per year if the distance is very huge. Dear students, recapitulate the definition of velocity. The displacement that occurs in unit time is called as velocity, and velocity can be calculated as displacement upon time. Always remember, CGS unit of speed and velocity is centimeter per second, while that of SI unit is meter per second. Both speed and velocity have same units. Speed is related to distance and velocity is related to displacement. Speed does not require direction, velocity requires direction. If motion is along the straight line, the values of speed and velocity will be equal. But if motion is taking place not in the straight line, means always it is changing the path, then the velocity will be not same as that of the speed, since the direction is changing. Let us take the first example which we have discussed previously in order to calculate speed of an object and the average speed of an object, as well as we will calculate velocity of an object. Dear students, in this example, the straight line distance between house of Sheetal and Sangeeta is 500 meter, and Sangeeta's house and school is 1200 meter. Also, the straight line distance from Sheetal's house to school is 1300 meter. Suppose Sheetal takes 5 minutes to reach from her house to Sangeeta's house, then the speed of Sheetal across this path is 500 upon 5, that is 100 meter per second. Sheetal's speed along the second path, that is the path B, is equal to distance travelled upon time, which is 1200 meter upon 24, that is 50 meter per minute. Now, Sheetal's average speed we can calculate by adding both the distances and both the piece of time. That is, average speed of Sheetal throughout her travel is 500 plus 1200 upon 5 plus 24. That is 1700 upon 29, which can be calculated as 58.6 meter per minute. If you will observe the straight path, that is the shortest distance which is covered by Prashant, and that is nothing but the actual displacement of Sheetal is 1300 meter. Time is same. So the displacement of Sheetal is 1300 upon 29 equal to 44.83. So here we will stop. We will meet with the next topic in the next period. Till then, keep on studying. Have a good day. Thank you.